So the restriction modification system involves it controls whether a particular bacteriophage can infect a host cell or not. If this host cell is, suppose it is a E. coli host cell strain C, within this cell lambda C phage can replicate and lyse the cell. It is the host cell for lambda C. So if it is a host cell for lambda C, then lambda C phage, the DNA of lambda C phage will not be restricted. It will go modification, or it has already gone modification in its DNA. With this same modification facility, the bacterial cell also protects its own DNA. The modification is basically methylation. The different places in the DNA are methylated, so that these are the sites where the restriction endonuclease will introduce cut. So if those sites are methylated, the site is not at all a substrate for the restriction endonuclease now. But if this lambda C phage infects another host of E. coli strain K, suppose, then in the strain K, this lambda C phage will not be able to survive. Its DNA will be restricted. It will be clipped into fragments by the restriction endonuclease system. So the whole system together is called restriction modification system. If out of 10 to the power 4 phages, one phage survives or forms plaques, then this phage had probably gone modification. It has gone methylation, its DNA, and so its DNA is getting protected. If this phage further reinfects the strain K, it will completely lyse the cell, and 100% plaque forming efficiency will be seen. So this is what restriction modification system is about. There are 3 types of restriction modification system. Those are called type 1, type 2, and type 3 systems. Among these 3 types, type 2 is most important, because this type 2 restriction endonuclease system is specific, means it introduces cuts at its original cleavage site, whereas these are non-specific. This is also non-specific. It introduces cuts about 1,000 base pairs away from the original cutting site, and type 3 also it incorporates cuts about 25-26 base pairs downstream of the original cutting site. Because these 2 enzymes have a cognate methylase activity, they have their methylase activity attached to the enzyme. That's why the site where they need to be cut, suppose this is the site where this enzyme has to cut, it methylates the site. While going to cut, it immediately methylates it, so the enzyme cannot sit here, it slips down to some other place and introduces cuts elsewhere, about 1,000 base pair on either on the upstream side or on the downstream side. Same is the case with this enzyme also. It also methylates the original site. But type 2 restriction endonucleases have a different methylase activity that is not attached with the restriction activity. So when restriction is taking place, no methylation is taking place. So it always introduces cuts at a specific site, making a specific ends or termini that can be ligated to another termini of similar compatible type. Type 2 restriction endonucleases, they require magnesium ion and ATP. But this type 1 and type 3, in addition to their requirement of magnesium ion and ATP, they also require S-adenosylmethionine for their activity. For today's purpose, let us end here. Then we will later see that there is a subversion of type 2 that is called type 2S type. So we will describe this type 2 and type 2S type in our next class. These are